This is, we got plenty of pictures of the sloths, and this was just showing that the viewer, now, Mona made a drawing, so this is Mona's drawing of the sloths. There's some other approaches. And one thing you can do with the drawing, like with that lettering up there, the green lettering on the light box, is you can extrude a curve out into 3 space. So you can print it on a 3D printer, even though it's a 2-dimensional thing, extrude it out. So this, what we're trying to do here is take a hand drawing of those sloths and actually make it a 3-dimensional object. There's the quadruped and the one standing. And so it's going to be extruded, and then we're going to print it on the printer. This, for some reason, has been giving us fits too, but we almost printed it. It's got a little problem. This is another free open, well, almost free open piece of software. It has a free version. We're only using the free version, and it's the type of thing that you find you have to use all the time. This is a program that can go through and clean up these scans that you got. Now, the thing that a scan gives you is really a point cloud in space. Think of just taking a laser pointer and going over to the sloths in the museum and just pointing the laser pointer at all the different places, and suppose your laser pointer could read the distance every time it hits something. Well then, if you put enough points there, you'd have a scan. Well, a point cloud is not a set of triangles. It's not a mesh. So the software always has to go through that point cloud and make it into a mesh that's supposed to be a surface. And there's lots of things that can happen. Vertices can be duplicated. So this red warning sign at the bottom, that's in the software. That means this ain't going to build, partner. So you've got to do something. And this program has various repair methods built into it. I guess the example I used this morning that I always think of is that Stanford decided that they would make a 3D model of Michelangelo's David, so they scanned it, but they wanted it to be high resolution. So it has 3 billion polygons in the scan of Michelangelo's David, and I was just saying you don't want to pick through those by hand. So you need software that's able to go through these things, sometimes smooth them out, sometimes fill holes. And there's a little code there that there's red, green, and yellow means you might have a problem building this part. Green means it's okay, and red means it's not going to build. So this was just our example. I thought, why not go ahead and use the examples we've been trying to do something with. This is a program called Blender. And Blender is a real workhorse program. Again, this is completely free and open. Blender is actually motivated by a bunch of people who want to make movies. And one of the people in New Blankets is in Hollywood. He actually worked for Deluxe, the cinema by Deluxe. And he said that Blender was a bunch of Hollywood wannabes. And he said that with great admiration because they were making free, open tools that could do what George Lucas and Industrial Light and Magic could do, and they're getting better every year. So every year the Blender Foundation releases a new feature animated film, and it's amazing to see year by year how their films come up in quality. So this is Blender, and I'll see if I can get to the screen that I want. Blender does a lot of things. Blender has, for example, there's a video I love on the web that's, I think, a 4th grader giving a tutorial on how to use Blender. Okay? And it's a great tutorial. And the way he builds something is there's an object in Blender called a sphere. So he takes a sphere, makes it a little bit bigger, gets another sphere, makes it a little smaller, puts it on top of it, takes another sphere, makes it, and he's got a snowman. And then, so when this video was made, there weren't very many 3D printers, but now he can easily be, printing his snowman. But one of the things that Blender does that's really handy for us is that it reads and writes a lot of file formats. So you might have people who are engineers and they're using AutoCAD. You may have people who have OBJ files, PLY files. It's an alphabet soup of different formats that people use. And so it's a great thing that there's this open source program that reads all those formats and writes the format that you want. So there's a kind of a lingua franca of 3D printers, which are these triangulated files, and they're usually STL files or OBJ files, and more or less consistent with each other. And this little Blender thing is just showing a process of, for example, suppose you wanted to make that sign there, that 3D sign that says Thinking PD and has the date. Well, those are just some fonts that are the same fonts you'd use in Microsoft Word or whatever. They're brought into Blender, they're extruded so that they're actually three-dimensional, and then there's a plate put underneath them. And so this little thing in Blender would show you how you do that in Blender. You bring in your text, you put a plate under it. And then you can do all the sizes. So this is the Thinking 3D logo and so on. And it's true, I guess that's just a commonplace with computers, that there are a lot of ways to do the same thing. And in fact, something you do in this, you might be able to do within the printer software itself. But also the thing that's true is that you might have, and I think probably on this machine there are a dozen or 15 different free software programs that are related in some way to 3D printing. But usually there's something that you can do with one program that's easier to do in that program than it is in others. So since you didn't pay, you don't have to worry about getting your money's worth or anything like that. Just go ahead and use the program that works for the thing you're trying to do. Oh, I didn't mean to do that. And you know, let each program do the thing that it's best at. Did somebody have a question? I'm just going to these. All right, and these are just the pictures we were going around. This brings up a topic. These are sideways and so on, but I think Mona was trying to change the mufflers on the slots or something that makes you down one of the. But it is possible to just take ordinary pictures and have a whole set of them and combine those pictures with software to get a 3D model out of it. Okay, so it uses statistical methods and so on. It's got a lot of gotchas in it, so it takes a certain amount of practice. But there are both commercial programs and free programs, and like I say, it depends on what your situation is, which you want to use. So a lot of people have seen this, but this is actually from a picture at the San Jose History Museum. It's called History San Jose, and this picture of a Model T4. Okay, and we got all those pictures because we're going to actually reproduce the car, which is actually a 100-year-old child's toy. It's a die-cast Model T4, but it's an accurate replica. So this was just the beginning stage, but I thought since I was leaving there and I wanted something for the gift shop and so on, we just make a sort of side plate, which was, this is the actual from the picture profile of that Model T4, and it just says History San Jose on it. But not much at this stage would really be probably described as turnkey. I mean, you've probably heard of a website called Thingiverse. And Thingiverse is a website of objects, and you can go to Thingiverse and you can say, oh, I like that bracelet, I like that trophy, I like that, what somebody said, there's a banjo-lele out there. So yeah, I've always wanted a banjo-lele. So anyway, you get it and send it to a 3D printer and print it. That's about as turnkey as it gets, because those models on there have usually been checked out to see if they will print and things like that. But most other things that you would try to do, they're not that turnkey, and they require some fiddling before you can actually get them to work. And that's true with a Connect-based scanner, with a commercial scanner, with other things. Even for example, if you want to do a whole 360-degree scan of some object, most scanners, even if they're expensive, you're going to have to do that by rotating the object somehow so that it will be in the field of the scanner. This is one that just came up actually in our demo on the 16th, earlier this week. In fact, I was on the phone with one of the doctors last night because he was following up with some ideas about this. This is actually an image from a plastic surgery application. And this is a child with a cleft palate that's going to have plastic surgery and is also participating in some of the pro bono work that the plastic surgeons do and so on, is helping them do fundraising, things like that. But part of the interest is just doing the surgery for, and by the way, we haven't been able to print this either. This turns out to be stuff as the trilobite was, and we can show you the model and see what's in problem. But this did not come from a desktop scanner, so it actually came from a camera, which is a special purpose camera. It's a binocular camera, and so it does stereo just like your eyes do stereo. It builds a depth map from the difference of these two images. So I thought maybe the person who had it was going to come today. She said she might. But anyway, she's in the neighborhood, and I think she's going to come over and let the museum take a few pictures. But this is just a camera that you walk around with like a regular camera, and it gives you a 3D model from just binocular stereo. I don't know if you know how people people's eyes work, but the fact that the two images on your retina are slightly different lets your brain construct the depth information. So that's some of the camera. And we haven't been able to print this yet, but we're not giving up hope. And the doc that called me that was talking to me last night, he wants to make stents for people that have aorta problems and are in danger of having aneurysms and so on. But the thing that's so adaptable to 3D printing is that he can combine this with actual physiological data. So he'll have the actual measurements from his scans of what the dimensions of the people's veins and arteries are. So when you make something with 3D printing, it can be one-off, custom, exactly measured and spec to the application that you want to use. And so he was thinking about and asking about materials that could go through a 3D printing process like this that wouldn't necessarily be plastic, but things that would be biologically safe. And in his case, he didn't want them to be reabsorbed by the body. Some applications people do, but he didn't. He wanted this to be. And so, you know, you can ask yourself, what is 3D printing good for? And some of the sarcastic news articles and some have said, like, oh great, you know, now I can get the 25-cent Chinese trinkets that I used to get by making them myself with a $2,500 printer, you know, but that's not really what it's about exactly. So, of course, you can print it with your name on it, but it's more about things that need to be one-off or things that, and you know, that is the point of rapid prototyping. A lot of rapid prototyping stuff is really going to be mass-produced. But the rapid prototyping is to get the working model before it goes to mass production. So some people probably know about lost wax casting, where you can take wax or the materials that will melt and fire those materials to make a mold. And then so the person put jewelry there, but actually one of the people that works with new blankets, his wife, has a gold chain. It actually has a moose on it. Her name is Michelle, and everybody calls her Moose. Don't ask me, but it's a gold moose head with antlers, and it was made on the MakerBot, but then lost wax cast to get a gold model. And so there's not really a restriction on the materials. I also want to say, because I forgot this morning, and I don't want to forget again, where 3D printing is right now is, you know, probably about where personal computers were in 1974 or something in terms of the technology. We have a long way to go. The business of scanning, which we've touched on, in other words, if there were scanners that were as affordable, as cheap as the printers themselves, and everybody keeps saying real soon now, and MakerBot actually has an inexpensive scanner to work. There's scanners built on the Connect and software that's one sort of bottleneck. The other bottleneck is the materials, and I didn't want to forget to say that people are working on devices that will actually let you recycle household plastics. So like your milk containers and things like that could go into a shredder and make filament and things like that. And of course that's a big change if people sort of got in the idea that these things would never get to the waste system, but you'd actually have an intended use for them. And you know, in one of my books, I think probably Silico Sapiens, I suggested in the future that all the materials that are used for packaging should also be barcoded or QR coded or something, so that a computer could immediately tell what the material is that any packaging is made out of, and that means that those can be recycled automatically without any of this stuff. But we have craziness with, you know, waste and so on, and that it's all aggregated into a big stream right now, which is a mess in the first place. So what you really need is some sort of a, you know, household garbage paper that's able to go through garbage and everything. But anyway, there will be 2 or 3 companies in the next year that are making machines that make filament or other devices out of common household things. And the, you know, poster child is the milk carton, because milk cartons are kind of ubiquitous, and that plastic isn't too bad. Okay, so this is kind of the final segment here. What I wanted to show you, this little interface, this is sort of what the driver's seat of the 3D printer itself looks like. Okay, this is called Repetier Host, and that little box there is meant to be a replica, or sort of a facsimile of the printing platform of the printer itself. So this is free open, and if you look for it, you'll see something called Repetier Host. This machine and that machine both are interfacing with Repetier Host. Hukabat, and the Saladoon.